Okay, we got 3 examples to get through to finish this perms and comms unit. And it's building on all of this stuff from yesterday, this whole expansion. But now we don't have to go as far in depth as that we did yesterday. Today, we're going to do some specific things. These are how your diploma exam questions kind of test that you can do a binomial expansion. So we're on page, I guess it's 370 in that note package, saying find a particular term. This isn't asking me to expand the whole thing anymore. As you can see, there's way less space. But it's saying, given 3x minus 4 to the power of 8, determine the middle term, like which one would be in the middle. This causes some grief for some people, except we know that because this exponent is 8, how many terms will be in this expansion? There's going to be 9 terms. So if there's 9 terms, which term would be the middle term? The 5th one. Okay? 5 in, that's going to be the middle. So we're actually looking for the 5th term. If I'm looking for the 5th term, and I'm going to write this equation here again so we kind of know what we're working with. Whoops, not C. NCK xn minus k y to the k. When we have the 5th term, we're actually talking about the t 4 plus 1, according to the equation. So the 4 is my k. Then we go in, we have to write this combination statement. NCK, n is always the exponent on this expansion, so that's the 8. Choose, now the k, in this example, would be what? 4. It's right there. Okay, the 4. The first term in this expansion is 3x, and the exponent on here would be 4, or 8 minus 4. So I'll just write it so we know where that's coming from, but that does simplify to 4. The last term in there is a negative 4. Remember that sign is important. So the negative 4 raised to the k power, which is 4. So now it's a matter of just crunching some numbers. What is 8 choose 4? 70. Then we look at the next part. This is 3x raised to the 4th power. So 3 to the 4th power is 81. And then x to the 4th power is just x to the 4th, which is nice. And then expanding negative 4 to the 4th power, remember a negative raised to a even power is going to turn out to be positive. So basically, pardon? 256. And then we're going to crunch this out. You're going to see that there's a lot of, or a big number here. What's the coefficient? So 1,451,520 x to the 4th. So this is what the question asks. It's saying, what's the middle term? So if I was to expand this out, this would have been the one in the middle. Because we first determined that there's 9 terms. 5th one in is going to be the middle term, and we just had to find that one part. So it's like yesterday we did the whole expansion. Now we just got to realize which term we're looking for. Okay? All right. Next example is doing something a little different yet. It's saying given 5x minus 2y, is that to the 9th? Okay, to the 9th power, find the coefficient of the term containing x to the 5th. So now it's not telling me my middle term. It's not telling me anything like that. We're just saying I need that part that has the 5th, or x to the power of 5. There's a little bit more thinking going on in this type of question. If we're looking at this, I want you guys to write this down because we're going to be using it in a different way right now. This is the expansion that we look at. I have no clue if this is the first one, the second one, the 3rd term. I have no clue basically what my k value is. Do I know my n value? Yeah, it's 9. So I'm going to start by saying that's 9, choose. I have no clue what that k value would be. I'm going to have to figure that out through a little bit of thinking. What does x stand for in this equation? The first term, which is 5x. So 5x, and then it's n minus k, so that's n minus, I don't know, because I still don't know k. And then the y, that's negative 2y to, oh no, that k power again. I don't know that k, but I could probably figure it out because this question says x to the 5th. So if I'm looking, this part right here is going to determine x to the 5th because that's where the x is. What would I have to put in that box to give this a power of 5? A 4, because 9 minus 4 is 5. So now that box is the same everywhere. So here's a 4, and here's a 4. So now we have enough information to find what they're asking us for. So 9 choose 4, 126. 5x to the power of 5. 5 to the power of 5, 3,125. X to the 5th. And then the last bit, we're saying negative 2y raised to the 4th. Negative 2 to the 4th power. It's a positive 16. Y to the 4th. And now we just go and find our answer. I think when we multiply these all out, 6.3 million. And then it's going to be x to the 5th, y to the 4th. Why is this a good answer? Yeah, it's just saying what's the coefficient. So that's the coefficient. The rest of it is x to the 5th, y to the 4th. But it's just saying, okay, what's the coefficient? Okay. The next question is quite similar, except I wrote over top of it for the exponents. What I want you to do right now is give it a shot. Same thing we just did. It's saying 2x to the 4th minus 2y squared to the 5th. What's the coefficient of the term containing x to the 12th? So same thing. Give that a shot. Okay, so this is the question set up. Same sort of thing. We're looking here. We know that the 5 is going to be our n value because 5 is that expansion, or sorry, the exponent on the binomial. So I have all the 5s set in. I have this right here being the first term raised to the n minus k. This thing being the second term raised to the k. And we're looking for something that's going to give us an x to the 12th. So again, here's where my x's are. That's where I got to look. I have a power of 4. I need to multiply that 4, raise it to a power that's going to give me a 12. So that means this chunk here better equal what? Better equal 3. What do I have to put in that box to get a 3? A 2. So if that's a 2, everywhere else is going to be a 2. 5 choose 2. That's 10. This thing should simplify to 8x to the 12th. The second term simplifies to 4y to the 4th, which again, it's just asking for the coefficient. So the coefficient in this case is going to be 320. I know in the full expansion, I'll still have x to the 12th, y to the 4th. Okay. This is probably the next example, and the last example is going to be probably the most trying for you guys because it's really coming down to a guess and check situation. And a lot of people don't, and myself included, get frustrated when you're guessing and checking, but this is the way to do it. Now let's take a look at what's going on. Given the binomial, so 3x cubed plus 1 over x cubed to the 6th power, find the constant term. So first off, word-wise, you need to know what constant term means. What is the constant term? What does constant term just mean in a grand scheme of things? Not in this example right now. You're getting a little bit too far, but what did you say, Austin? There's no variable. Okay, so it's not a binomial, just there's no variable. So plus 10, plus 4, whatever, if all your variables cancel out, that's your constant. So in this case, saying given this, find the constant term. We left the work in here so we wouldn't have a lot to do, but we're going to explain it. Saying in order to find this k value, just like we've done those previous examples with those little boxes, we have to put everything into the formula that we know. So here it is. First term, last term, and we left all those k's open. In the example above, we used little boxes, so you're still free to use little boxes in this case. But like they say, the constant term is going to happen when all the x's canceled out. So this guy said, what if I try k being 0? And he puts in all the information. K being 0 gets me to a 15th power here. This turns out to be a 1. So I'm still left with an x to the 15th. That's not a constant. So we try something else. K equals 1. He puts a 1 in. He gets this over this thing to the power of 1. There is a simplification going on. X to the 15th over x cubed. Well, that only gives me x to the 12th. It didn't all cancel out. So he keeps trying and trying different values of k. And when he gets to trying k is 3, and obviously you can jump around and check what you think is going to work closer, he's saying, okay, right here, that'll give me x cubed raised to the power of 3. That's x to the 9th. Right here, this will give me 1 over x to the 9th, which is x to the 9th over x to the 9th. That cancels out to 1. All of my variables are gone. Therefore, the constant term is happening when k equals 3. So you have to check to see when things are going to cancel out. And then you put the 3 back in for those boxes and figure out the exact same way we've done everything else. But there is a matter of some guess and check going on. Okay? It's not fun, but it's not hard either. Okay? Most of it is pretty straightforward. You're never going to be asked for a constant term if there isn't something on the top, something on the bottom. Like nothing would cancel out. If this thing was 3x cubed plus, I don't know, 4x cubed, there would never be a constant term. Nothing would ever cancel out. Okay? But we need one on top, one on bottom. So that's it. And that kind of ends the binomial expansion thing. So one of the easiest thing is actually to expand it out like all that work we did a few days ago to get all the expansion. That's the easiest. It's the longest. And then it gets into these situations where what can we ask to see if you actually understand the formula? Well, one of them, what's the middle term? There would be no middle term if this thing was an odd number. If the power was an odd number, you can't have a middle term. Because if I had 8 things, there is no middle. So it'll always work out that there has to be a middle. Find the coefficient containing this. We had to set up those boxes and determine our value of k. We did 2 examples like that. The last one for the constant, it's the same situation. You set it up and you try values of k until your all your variables kind of cancel out, delete to 1. Make sense? So, I'll throw this in the video as well, that your test on this is going to be Monday, not tomorrow. Okay? No, Jacob, Monday isn't tomorrow. Liberals don't rule the world on YouTube for everybody to hear. So, test on Monday.